This is the 7th video in the beginning programming series. And what we're going to do in this video is we're going to use the knowledge that we've got so far about programming to create a simple light show on the Jackboard itself, using the Jackbord's internal LEDs. For more information, visit jb.works and at the search prompt enter the TMT code shown at the bottom of the screen. Before we get going on the program, let's just have a quick look at the idea of RGB LEDs. So first of all, an LED is basically a light emitting diode, and they are little electronic semiconductors that emit light. An RGB LED is basically a type of LED like this one down here. And what it is it has 3 normal LEDs inside it. And one of them is red, one of them is green, and one of them is blue. And what that means is that this one LED can actually create just about any color you want. And it does that by combining the amount of light from each of the colors that are in the LED. So for example, here we've got 3 circles. We've got red, green, and blue. And by combining them in different ways, you can generate other colors, such as, in this case, yellow, cyan, and magenta. And then, of course, in the center, where you combine them all together, you get white light. And so an RGB LED basically lets you generate just about any color you like. And in fact, the screen that you're watching this video on, and your TV set, a Chromebook, etc., even a phone, if you look at the screens very, very closely with something like a magnifying glass, you'll see that they're actually composed of hundreds of thousands, if not millions in some cases, of colored pixels, and these will be red, green, and blue. And that's how the picture is created on your device. So the Jackboard has a number of LEDs and RGB LEDs built in. The first one is the User 1 LED, which is on the front of the Jackboard between ports B and port C. And this is the LED that we're going to be using today. The others are actually inside, and one of them's on the underside of port C, the underside of port E, there's another one on the underside of port on the power port, and finally there's one under port A. And you'll notice that each one of them has a pin next to it. And for us, for user LED number 1, we're using pin L1. And likewise for user LED number 5, it's pin L5. So you can basically use the user LED pins in the same way that you would use the normal pins, like port A, B, C, or D. So for example, if you wanted to turn on the front user LED, you would simply use L1 space 1 on the command line. Just like if you wanted to turn on port B1, you would use B1 space 1 on the command line. So these are the user LEDs. And now let's take a look at a wee demo of them in use, particularly the User 1 LED. Now, as I just mentioned, we're going to use user LED number 1 for this video. And that's controlled with port pin L1. So if I want to turn it on, I type L1 space 1, and I'm in the command page here. And so that turns it on and it becomes white. And likewise, if I want to turn it off, I go L1 space 0. Now, you can also set the color of the LEDs. So if I wanted to make it red, I would type L1 space 3. And I know that the code for red is 3, and there'll be a table of them later on, so don't worry about it now. And likewise, if I wanted to make it green, I would type L1 space 8, and that makes it green. And finally, if I want to turn it off, I go L1 space 0. So you can use these methods to control the User 1 LED. These are some resources that you can find on jb.works. They all have TMT codes associated with them, and to use those, as you know, you go to jb.works, put it into the search prompt, press enter, and it will take you directly to the page. The first one is just about controlling the user LEDs. It's an activity. This one is using RGB values to control the user LEDs. This is the LED color table that I was telling you about before. So it lists the colors, numbers from 1 to 15, and the corresponding color for each one. And then finally, this guy describes the light stick, and that's a really cool thing as well. So that gives you more detail on using RGB LEDs. To get the program for this video, basically adopt your Jackboard, and then once you're on the dashboard, navigate to the program page. Find a slot where you don't want the code that's already there and you can get rid of it, so we'll just select this and delete it. And then come over to the right hand side and just click on the Guide tab and search for LIGHT show, light show. And this is the program that we want. Now what you can do is, you see there's a copy code button here, so just click it and that selects all of the code here and copies it into the clipboard for you. So all you need to do is come over to the left hand side and basically paste the code in, and that's it, and save the code. Now that we've got the program loaded, let's run it. So you'll see on the top right hand corner here there's a picture of my JackBords user LED. The colors on yours will look a lot better than mine because the video camera is not very good at recording the LED colors. So in the meantime, just click on the Print tab and then click on the rocket to run the program. And you'll see what it's doing is it's telling you which color it's showing, and on the Jackboard itself you can see the colors change. So we started off at 1 and got all the way up to 15. So remember I said earlier that there was a table of colors. So if you just click on the Progref tab and just search the word color, and the one that we want is this one here. And so this is a table of all the colors that are available for basically available for use with the user LEDs. So it starts off at 1, which is dim white, and goes all the way to 15, which is magenta. These are red, green, and blue values, but you don't need to worry about them for now. Now that we've run the program, it's time to have a look at the code that made it do what it did. And in particular, we're going to be looking at variables. There's a delay in there, and also a time when we need to make a decision. So let's take a look at the code now. So this is the code that produced the result that we just saw. So as usual, we have the multi-line comment, and it's always a good idea to have this because first of all, you can say what your program is and give a brief description of what it does. Next, we come to the first task, which is the prog_vars task. And here we are declaring two variables. The first one is called LED_color, and that's declared as an integer, and we set the initial value at 0. And next we have LED delay, and that's set to 500, and that is a delay in milliseconds. So these are two integer variables that we are using. Next, we come to the prog start section, and what this does is it's the setup area where we get everything set up the way we want it. So the first thing we do is we clear the print tab. Then we turn off all of the user LEDs with the loff command. And then finally, we just print the title light show, and you can see that down here. Next we come to the program loop, and it's called the program loop because the program will loop here forever, and this is where it does most of its things. So the first thing we do is we take the value of the LED color variable and we use the inc command, and what that does is it increments the value, and that's why you see them going from 1, 2, 3, 4, 5. It's because this command is incrementing the value of this variable. And then beneath it, we print the current color, which is what you're seeing on the print tab over here. The next thing we need to do is take the color that we have now set and use it to set the user one LED. And remember before how when we were turning it on and off, we just went L1 space 1, L1 space 0, and then we could do L1 space 3 to make it red, etc. So all we're doing is substituting a variable called LED color for the numeric value that we were typing in by hand earlier. Once we've done that, because we want to actually see the change, we have a delay. So the DLY command is basically delay. And we delay for the number of milliseconds stored in the LED delay variable. And if you remember, it was set to 500. So basically we are waiting here for half a second. And then finally we come to the decision. And that's what we're doing here. And what we're saying is that if the LED color is greater than or equal to 15, we want to exit the program. So we want to stop running the program. So you can see on the right hand side here, it goes 1, 2, 3, 4, 5, 6, 7, 8, carries on. But as soon as it hits 15, because the LED color is greater than or equal to 15, it exits the program. And when it exits the program, it drops down into the prog stop task. And basically the first thing we do is we turn all of the LEDs off, like we did up here in the prog start task. And finally we print the word bye. And there we have it, bye. So this is how the program works. Now that we know how the program works, let's see if we can learn something by changing it and doing different things to it. So one of the things we'll do is change the delay. We'll add some more of the user LEDs, so the other ones, because remember we've got 5. And let's try getting some different colors in there as well. So the first thing we're going to do is let's change the delay. So let's make it a lot longer. So we'll double it. We'll make it 1 second. So if I now run this, yeah, it takes a lot longer. So that's going to take 15 seconds. And you can see the colors are around for longer as well. So all we've done is we've taken this variable, which is LED delay, and just changed it so that when the delay command comes to run, it sees the new value, and that's why we get the longer delay. So the next thing is we want to add some more LEDs. So I'm going to reduce that back to 500 because it's kind of slow. Remember how we've got turn the user LED on here, and we've got L1. So let us add L2. So go L2, LED color. And now when I run the program, you should be able to see, if I put something white here, you should be able to see the color change for the second LED because it's just under port C. So let's run it. And there we go. So it's basically becoming the same color as the first one. So what we've done is down here, we've added in a new user LED. If I wanted to have all of the user LEDs be set to that color, what I could do is go L on and then LED color. So I go LED. And I can get rid of these two because I don't need them anymore. Because what will happen is L on will set all of the user LEDs at the same time to the same color. So let's run it and see what happens. So yeah, when you look at your Jackboard, you'll see that all of the user LEDs are the same color. So the other thing we were going to look at is using some different colors. And there are two ways you can do this. One is you can try using the RGB values, but we won't do that for this video. What you can do is this. Instead of putting them all onto the same color, we would go L1 space LED color. Then we increment LED color and set L2. So we go L2 slash LED color. And then we increment it again. And we go L3, LED color. So what that's going to do, LED color. So what that's going to do is it means that L1, L2, and L3 will each be showing different colors. So let's run it and see if that happens. And yes, they do. But the problem is you will have noticed that it only goes 1, 4, 7, 10, and 13, and then it stops. So what we can do is you see down here we've got this any statement here, which basically is the one that sees that the LED color has got to 15 and then it exits the program. So let's just comment that out altogether. And what that will do is our program will now run pretty much forever. So if I click on the rocket, it will just keep on running. Now you might have noticed that the color numbers are increasing way beyond 15, which we really don't want. So let's stop it. So what we need to do is we need to go back to this any statement here. And instead of having it exit the program, we are going to get it to reset the LED color, so LED color, back to 0. So now what should happen is the LED color on the right hand side is going to cycle from 1 to 15. Well, 1 to 13 in this case. You see that? And likewise, the colors are changing. So the first 3 user LEDs have different colors. So if we stop that now, it only went up to 13. And that's because we're incrementing it here. And then we're saying greater than or equal to 15, and it resets it back down to 0. But because we're doing the reset down here, we don't actually get to see the value up the top here. So that's why it only seems to get up to 13. So there are other things you can do as well. For example, adding more of the user LEDs. So for example, get all 5 having different colors. Try different delays. You'll find you'll reach a point with the delay. So if I drop it down to 100, where it'll be so fast that you'll actually have trouble seeing the colors. So there are all sorts of things that you can do. For more information, visit jb.works.